Welcome to the explanation video for the February test of the Summerfield Open. Our first question deals with Las Vegas. I'm playing roulette, and there is a 5% chance that I win $4 and a 35% chance that I win $1. Of course, if neither of those two happen, I lose $1. If I played this game 1,000 times, what would I expect to win or lose? Well, we're going to create a table that has the probability, the number of times something happens, how much I win or lose each time something happens, and what my total win or loss is. So let's fill out the probability table. First, there's a 5% probability. And if I play the game 1,000 times, that means that 5% probability will happen 50 times. Remember, 5% is 0.05. So 0.05 times 1,000 is 50. 5% of the time I win $4. So of all those 50 times this happens, I can multiply that out and I would win $200 just on this part of the game. There's the 35% probability, and that means if we play the game 1,000 times, that would happen 350 times. And those 350 times I would win $1 each time. So 350 times $1 would be $350. But then we have to figure out the probability of losing. Remember, whenever you do games a chance like this, probabilities should always add up to 100%. So if there's a 5% probability and a 35% probability, that means the leftover probability is 60%. If something happens 60% of the time and you do it 1,000 times, you would expect that to happen 600 times. But this is where we lose $1. And if you take that loss of $1 times 600, we would expect to lose $600 here. Now this is everything, and we can add up that total win-loss column of $200 plus $350 minus $600, and that gives us our answer. We would expect to lose $50 if we played this game 1,000 times. Just as a general rule, Las Vegas is a great way to think about probability because literally that's an entire industry built on probability and really smart people understanding how they get that little edge to build magnificent hotels and just an absolute wonderland in Las Vegas. Question number 2. Income equals 20,000 plus the number of years of education times 2,000 plus the number of years of STEM education in college times 12,000. What would you expect to make if you had 17 years of education and 4 years of college STEM classes? Well, we have an equation where there's an I, an E, and an S. We don't know the I, but we know the E is 17, and we know the S is 4. We can take that equation and just plug in the E and S, so we'll have 20,000 plus our E, which is 17, times 2,000, plus our S, which is 4 times 12,000. If you multiply and add these together, you get $102,000. That's a pretty good income, especially for taking 4 years of college STEM courses. Just for fun, think about what you would make if you didn't have those STEM courses. Question number 3. I can normally run at 7 miles an hour. However, if I listen to heavy metal music, I can run 25% faster. How far can I run if I play the song Welcome to the Jungle? And that song happens to be 5 minutes, incidentally. Well, the first thing we need to do is we need to figure out how fast I'd be running. I'm going to run 7 miles an hour, but 25% faster than that. So we can take 7 times 25. Remember, 25% is 0.25. 7 times 25%, and that equals 1.75. So I'm going to run 7 miles an hour plus 1.7 miles an hour faster, which equals 8.75 miles per hour. I could do that in one step if I wanted by just multiplying 7 times 1.25, and that equals 8.75 miles per hour. Either way, you get the same 8.75 miles an hour. Then we need to figure out how far I go if I run 5 minutes. Remember, miles per hour is in hours, but the time we run is in minutes, so we have to convert that. Probably the easiest way to do that is to convert your minutes to hours. So if we run 5 minutes, we can take 5 divided by 60, and that gives us 0.0833 hours. Then it becomes pretty easy. You just multiply your speed, 8.75 miles per hour, times your time, 0.0833 hours, and you get 0.73 miles. Question number 4. I promised you this would be on the test. I hope you were ready for it. I have $10,000 and I want it to triple in 15 years. What interest rate would I need? So we've talked about this a lot. This is the equation we want to use. Take the amount of money you start with, multiply it by 1 plus your interest rate raised to the number of years, and that'll equal the amount you end with. Well, in this problem, and you can simplify that to s times 1 plus r raised to the y equals e. In this problem, we know we're starting with $10,000. We don't know the interest rate. We know the years is 15 years, and we know we're going to end with $30,000, which is $10,000 tripled. We can plug all those numbers into the equation, and we get 10,000 times 1 plus r raised to the 15th equals 30,000. The first thing we can do is divide both sides by 10,000, and we get 1 plus r raised to the 15th equals 3. But remember, that 15 in the exponent is a little tricky. How do we get rid of that? Because remember, whenever you do an algebra equation, you want to get the variable by itself. So we want to get the r by itself. In order to do that, we have to get rid of this exponent. Well, we talked about that example. If you have x to the 5th, and then you raise that to the 1/5, those 5s will cancel out. Well, we can do the same thing here. We can get rid of that exponent, that 15 exponent, by raising both sides to the 1/15th. So now we have 1 plus r raised to the 15th raised to the 1/15th, and we have 3 raised to the 1/15th. We're allowed to do that in algebra because we raised both sides to the 1/15th. Well, the good news is the 15 and the 1/15th cancel. And so we can do this algebraically really quickly. We can take 1 divided by 15, that will give us 0.06667. And then we can just raise 3 to that. So we do 3x to the y, 0.06667, and that gives us 1.07599. So if you go back to our equation, we have 1 plus r, the exponents have canceled, so 1 plus r equals 3 to the 1/15th. Well, 3 to the 1/15th equals 1.07599, so 1 plus r equals 1.07599. Subtract 1 from both sides, and you get r equals 0.07599, or 7.6%. And that's your answer. So if I wanted to triple my money in 15 years, I would have to earn an interest rate of 7.6%. Here's another compound interest question for you. Adam and Peter both have $10,000 for college. They both invest that money for 20 years. If Adam invested at 8% and Peter invested at 9%, how much more will Peter have after 20 years? Hopefully this will be a shocking answer to you about the power that just 1 extra percent has when you compound it over several years. So remember, we have this equation that we've always been using for compound interest now. S equals 1 plus r raised to the y equals e. S times 1 plus r raised to the y equals e. Well, for Adam, we know he starts with $10,000. He has an interest rate of 8%, and he has y equals to 20, and we don't know e. Well, we can put that in our equation, 10,000 times 1.08 raised to the 20th, and that equals $46,609.57. Just as an aside, that's an amazing amount of money to go from $10,000 to almost $47,000 just by interest. And that really shows you the power of compounding. Peter, on the other hand, has all the same stuff. He starts with $10,000. He has 20 years, but instead of 8%, you see it's highlighted in red, he has 9%. We do the same equation, 10,000 times 1.09 raised to the 20th, and that gives us $56,000, $56,044.11. We can subtract those, $56,044 minus $46,610, and that gives us our answer, $9,435. How many of you, when you first read this question, would have thought that Peter would end up with almost $10,000 more than Adam when both of them just started out with $10,000, and all Peter did was get 1 extra % interest. Again, that really tells you the power of compounding. It's such a powerful concept. Here's the last question. There are 6 runners in a race: Amy, Bo, Cindy, Dave, Elle, and Fred. Did you guys notice the first letter of all those names? They do that a lot on LSAT tests. So if you ever want to be a lawyer, you'll come to love those A, B, C, D, E, F names. If all you care about are the first 3 finishers, how many different combinations of first, second, and third place are there? Well, let's think about this for a second. Let's break this down. How many different combinations are there of first place? Well, there are 6, right? A could come in first, or B could come in first, or C could come in first, or D or E or F. So there are 6 total ways that could end. Now, we need to look at each of these possibilities, but just for the example's sake, let's assume that C won. Then, after C won, there would be 5 different ways that someone could come in second place, right? If C won, then A could come in second, or B could come in second, or D could come in second, or E or F. You'll notice C isn't there because C already won. So we know there are 6 different ways that you could have a first place finisher. And then after you have a first place finisher, there are 5 different ways you could have a second place finisher. And then again, let's just assume B won. And then there are 4 different ways you could have a third place finisher. Obviously, you don't have C or B in the third place because C came in first place and B came in second. And you'll notice that pattern there, the 6, 5, 4. And that's that factorial pattern we were talking about a few tests ago. And this will start to give you your answer. If you took 6 times 5 times 4, that's going to give you 120 different combinations, and that's your answer. And we got that because there were 6 different ways you could have a first place finisher. And then there were 5 different ways you could have a second place finisher. So if you multiplied 6 times 5, there are 30 different ways you could have a first and second place finisher. If you took that to third place, there are only 4 different ways you could have a third place finisher. You just do that again, 6 times 5 times 4, and that gives you the right answer, 120. Well, we've done 5 of these now. Great job, everybody. Like I always say, these tests are not easy. I was telling some friends that I write this at the 6th to 8th grade level, and one of my friends who knows about this test said it would be really impressive if an 8th grader got all those questions right. So just the fact that you 4th and 5th graders are doing this is absolutely fantastic. I'm so proud of all of you. Great job, everybody, and I'll see you next time for the March test, which will be March 21st at 3:15 at Summerfield Elementary.